Hello and welcome to my explanatory video series on machine learning. Today, I am diving into the world of convolutional neural networks, or CNNs, and how they can be applied to medical image segmentation. Medical image segmentation is a crucial process in healthcare, assisting in the diagnosis and treatment of various medical conditions. Today, we'll explore 3 different machine learning methods applied to this task: supervised learning, unsupervised learning, and stepped learning. Supervised learning. Supervised learning is a machine learning technique where a model is trained on a labeled dataset. In the case of medical image segmentation, this means that the model is provided with both the input, the medical images, and the desired output, the segmented images. For instance, a dataset might consist of MRI scans along with corresponding images where the regions of interest, such as tumors, are manually outlined by experts. The goal of the CNN in this case would be to learn to accurately segment these regions based on this training data. The model's performance can then be evaluated by comparing its outputs to the true labels in a separate testing set. Unsupervised learning. Unsupervised learning, on the other hand, is a technique where the model is not provided with any labels. Instead, the model is given a dataset and tasked with discovering underlying patterns or structures within the data on its own. In the context of medical image segmentation, an unsupervised approach might involve the CNN finding clusters of similar pixels or structures within images. However, without labels to guide the learning process, the model won't necessarily segment the images in a clinically meaningful way, making this approach less common in practice for medical image segmentation. Stepped learning. Stepped learning is a newer method where training is broken down into a sequence of steps or stages, each with its own task. This allows the model to gradually learn increasingly complex features or concepts. For instance, in medical image segmentation, a CNN might first be trained to recognize basic features like edges or texture in images, a task that may not require labeled data, then be trained to recognize more complex structures like organs or tissues, using a smaller set of labeled data, and finally be trained to perform the final segmentation task. This approach can potentially use data more efficiently and achieve good performance even with less labeled data, but requires careful design of the learning steps. In summary, the right learning approach for medical image segmentation using CNNs depends on the available data and the specific requirements of the task. While supervised learning can achieve high accuracy given a large labeled dataset, unsupervised learning may be useful when labels are hard to obtain. Stepped learning presents a middle ground, allowing the model to gradually learn from simple to complex tasks, which can be particularly useful when labeled data are limited.